Let's look at another example of a triangle congruence proof. Once again, I'm going to do these proofs in two ways. One, more traditional, the two-column proof. And in the next chapter, on the next slide, I will do this as a flow chart, which you'll see some newer textbooks using. So if you're going to a school that uses flow charts, you maybe could just skip to the next chapter to see the example done that way. All right, let's check out what was given to us. We were told that AB is congruent to CB. Mark that in. And we're being told that BD bisects AC. Well, remember, a bisector cuts something in half. So these two sides must be equal because that's the definition of what a bisector does. It cuts something in half. And I'm also going to mark this in. I'm probably going to use that reflexive property. To me, it looks like we are going to aim for side, side, side. So let's begin with what was given to us. I'm going to drop this down just a little bit, and you'll see why. Oh, let's do this. AB was congruent to CB. This was given. Next, I like to write down, okay, BD bisects AC. That was given. Now, once I have that, I like to say, well, what does that tell me? Well, what that tells me is that AD is congruent to CD. And how I know that, my reasoning is, that is the very definition of a bisector. It cuts things in half. Okay, so now I've established two sides. And of course, we've got to say that BD is congruent to BD by the reflexive property. So here again, we established a side, another side, and the third side in our proof. So I can say that the two triangles are congruent by side, side, side. If this proof helped you, please like and subscribe for more geometry proofs. All right, so let's mark in what was given here. We were told that AB and CB are congruent. Then we were told that BD bisects AC. Now what that means is that it cuts it in half. That's what a bisector does. So that must mean that these two sides are equal to each other. And of course, we can use that reflexive property to say that they share that side. To me, it looks like, of my four theorems here, like we're going to use side, side, side. Now this flowchart adds kind of a level to it. What I mean by that is I'm going to start here with just, my given that AB is congruent to CB by being given. Now, I would also like to say that AD and CD are the same, but first I have to establish my other given piece. So I'm going to write the BD, put the box around to make it look like a flow chart here, bisects AC. That was given. And what that gives me, or what that tells me, is that AD is congruent to CD, because that is the definition of a bisector. It tells me things have been cut in half. And finally, BD is equal to, is congruent to CD by the reflexive property. Now, this adds a level to my my flow chart because I was given this bisector thing, and I need to state that. Okay, BD bisects AC. Then in the next level, I have to tell me what I know from that given. So your given statement should really, still come first. But this given right up here was not enough to just go right to the fact that those two sides were the same. I needed to use my reasoning here. So then we can come down and say the two triangles are congruent by side, side, side. If this video helped you, please like and subscribe for more geometry content.